All right, chapter 7. We are doing exponential growth and decay here. So if we are looking for growth or decay, we got to figure out what our growth or decay factor would be to tell if it is growth or decay. So when you look, this number right here, remember it's a times b to the x power. That's your growth factor. If that's a number less than 1, it's decay. So this would be decay. And then whenever we plug in a 0 for x, we would get our intercept, y-intercept. So 0.85 to the 0 power is 1. So this number, that a term, always ends up being your y-intercept. So we would say this is a decay with a decay factor of 4, okay? This one is a growth factor because it's a number greater than 1, and your y-intercept is 18, okay? Then it says evaluate each log. Remember you ask yourself the question on these, what could I I'm saying that wrong. 9 to what power would equal 81? Right? So 9 squared would equal 81. So our answer would be 2 here. Okay. This one's 64 to what power would equal 4? You gotta kind of think backwards here, right? 64 fourth rooted will get you 4. So we think of it as, cube rooted, not fourth rooted, would get you 4. So we think of it kind of like this, right? It's the cube root of 64, but that cube rooting is the fraction 1/3. So it's 64 to the 1/3 power will equal 4. Okay, now this one's probably the trickiest. We're saying 4 to what power? My question marks are struggling. Equals 8, okay? So if you think about this, if we square root 4, we would get 2. So that's 4 to the 1/2 power. But then that's going to get me 2, and I need 8. So then I need to cube that, essentially. 3 and 1/2 would be 4 to the 3/2 power. So that's our answer. 4 to the 3/2 power is going to get us 8. Okay. All right, next one. It says Robert invested $800 in a bank account. The year has an annual interest rate of 5.5%, so started with 800. How much money will be in the account after 12 years? So we're going to plug this into our growth function. So it's our starting amount times, and then it's 1 plus the percent, right? We want 105.5%. We don't want 5.5% or our number's going down. So 1.055 is the number we're going to plug in there. And then after 12 years, so we're going to put it to the 12th power. And when you plug that into your calculator, you get $1,520.97. Okay? How much money if it's compounded continuously? This is PERT. Remember PERT? P-E to the R-T. So our principal, our original amount, is 800 times E. That's not an E. There it goes. Our rate is Guys, my thing doesn't want to write right now. Let's try this. There we go. 0.055. Our T is 12 years, so times 12. And then you would just plug that into your calculator, and you get A equals $1,547.83. So it definitely pays to compound continuously. When you compare those two numbers, you're making more money. It's just not typically an option. So, all right. Number 9, solve for x. We are going to try to get our x by itself, but the first thing we need to do to get there is we're going to divide by 23. Okay, so e to the 2x power equals, you guys get serenaded by my daughter, 1.7391. Okay, now remember when that exponent is there, the way that we get this is we take the natural log of both sides. So that's going to get rid of our e. So if we take the natural log on this side and we take the natural log on this side, what happens is these pretty much get rid of each other. So we're just left with 2x over here. And then you would plug in the natural log of 1.7391. And then from there, divide by 2. So whatever you plug in here, then divide by 2, and you get x equals 2767. All right, next one here. When we are doing 2 to the x equals 5 and solving for x here, if you recall, if we take the log of both sides, so basically we're saying the log of 2 to the x equals the log of 5, and then we take this x and we move it out in front. So it's x log 2 equals log 5, and then we divide by log 2, divide by log 2. Remember that parenthesis here? That really matters. When you plug that in, log 5 divided by log 2, you get x equals 2.3219. Okay, I hope I'm not going too fast for you. If I am, I'm just trying to make sure you get what you need, but don't have to sit through 2 hours of video to get there, which it might still be that long, I'm sorry. But ask me questions, shoot me emails if you're stuck on something. Okay, number 10, change of base. Remember, this is the one where you do the log of the base over the log of your drop-down number here, 32. So log 8, don't forget that parenthesis because it starts one here. You got to finish it off before you can divide. So this comes out to 0.6. Okay. Number 13. So one sec. All right, number 13 says, oh, it's comedic how much noise there is in a house with 5 people in it, huh? Really sorry for all the noise. Use the property of logarithms to solve the following logarithmic equations. So this we're kind of do the reverse of what we did before. We're going to take this 2 out in front and we're going to make it an exponent again. So it's going to be log of 5 squared, so log 25 plus log x equals 2. And if you recall, when we're adding, when they're both, log something and log something, when we're adding them, we're actually going to multiply. So writing it in this form, log 25x equals 2. Okay, and now we're going to write it in exponential form. And if you remember, it's as if there's a 10 right here, right? So we're saying 10 to the second power equals this. So we're going to write this. Let's zoom in a little because I'm running out of room. We're going to say 10 to the second power equals 25x. Okay, so that's 100 equals 25x, and then we just divide by 25. So x is 4 for that one. Okay, similar concepts here. When you look at this, again, we're adding, okay, so we're really going to multiply. So it's going to be the log. Now I'm going to multiply these. So I'm going to do x times x minus 21 equals 2. And then if we simplify this a little bit, okay, this is going to be base 10. So 10 to the second power equals, and then I'm going to go ahead and distribute this, x squared minus 21x is what it's going to be equal to. And then we can solve from here by taking away 100 from both sides. Let's just write it up on the line. So minus 100. So right now we have all of this. This is 0 equals this? Well, we can factor. So if we make our little x here, what can we multiply to get negative 100 that we can add to get negative 21? And that would be a negative 25 times a positive 4. So it's going to be x minus 25 and x plus 4, which means our values here, we're going to have x equals x equals positive 25 to make this 0, and negative 4 to make that 0. But now here's the deal. If we go back up here and we plug it in, you cannot take the log of a negative number. So this does not work, and our answer is just x equals 25. Okay, number 15. Now this one's subtraction. Remember, subtraction correlates with division. So we're going to say it's the log, and then we're going to divide. Remember, we're writing this as a single log is kind of how they always said it. We're going to divide, so 4x on top and 5 on bottom equals 3, okay? And this is still base 10, so we're saying 10 to the third power should equal this. So 10 to the third power should equal 4x over 5. And then you can just think of it, well, let's just write it out like this. 10 to the third is 1,000 equals 4x over 5. So we're going to multiply by 5. So 5,000 equals 4x, and then divide by 4, and you get x equals 1,250. Okay. All right, moving on. This one says, the population of a bee colony is growing at a rate of 2.3% each year. Currently 3,400 bees in the colony at this rate, and how many years will there be 10,200 bees in the colony? So we're going to write this, our total, 10,200 equals, and this is exponential growth, so our original amount, 3,400, times our rate, which it's growing at 2.3%, so it's 102.3%, but as a decimal, that would be 1.023, okay? And then we're trying to figure out the time. We're trying to figure out how many years. So it looks like this. I'm going to start by dividing by 3,400. So we get 3 equals 1.023 to the t power. And now this, we're going to write in logarithmic form. So if I take the log of both sides, it would be log 3 equals the log of 1.023, and then there's this t here, but remember when it's an exponent, we're going to move it out in front of it all, so I'm going to put the t here and ditch it over here. Okay, so then from here, if we're trying to isolate t, all we need to do is divide by log 1.023, divide by log 1.023. Don't forget that parenthesis there, and you're just going to plug that into your calculator, and what you get is t equals 48.313, and they were asking how long. This is years, so that will be your answer. Okay. Number 19, a certain substance has a half-life of 14 days. How much will you have left after 90 days if your original sample is 75 milligrams? So remember, with half-life, we're going to take the original amount, just like with exponential growth, right? Original amount goes first, and then your growth factor, it's half-life, your decay factor, half-life, so it's times 1/2 always with half-life. And then your exponent is a ratio, something over something. The bottom number is always the half-life. So it says it has a half-life of 14 days. And your top number is what we're looking for here. How much will you have left after 90 days? So we're gonna put a 90 here. And then you would just plug that into your calculator. Make sure that you put parentheses around that when you plug it in. And you get y equals 0.8707. It's saying how much will you have left? You will have that many milligrams, so not much. Okay. All right. Number 3 here, chapter 7 still. Which of the following functions represents exponential growth? You're just looking at this number, that number, that number, that number. The only one that is more than 1 is B. So that's exponential growth. Number 5, it says use the change of base formula to rewrite this using common logarithms. And we just did one of these earlier. You're taking the log of 16 and dividing by the log of 7. So that would be letter D. Okay. Next page. It says which of the following is 2 times the natural log of 10 minus 5, or natural log of 5, written as a single natural logarithm. Remember, this becomes an exponent, and then subtraction means division. So we're taking the natural log of 10 squared divided by 5. Okay, when you do that, that's 100 divided by 5, and 100 divided by 5 is 20. So you really have the natural log of 20, letter D. Okay. This one, which of the following is the correct expansion? So now we're stretching it out. So remember, multiplication means addition and division means subtraction. So if we're dividing here, we're actually subtracting. And if we are multiplying here, okay, we're actually going to be adding. So when we look at this, okay, this 2 is going to move out in front of our log. So it's going to be 2 log 6 x plus, and then log y, log base 6 y, and then minus, and then this 4 is going to move out in front, so 4 log base 6 z. So that would be this guy right here. Okay. All right, number 11 says for the years 2000 to 2005, the median price of a single family home in the United States can be approximated by the exponential function, this, where t is the number of years after the year 2000. Okay, so first question is, what is the growth rate of housing prices? If you look at this number, remember growth rate, you have to add 1 to it. So our growth rate is actually the 0.087 part. Move that over, so it's an 8.7% growth rate. And then what is the median price in the year 2005? Well, it's every year after 2000. So 2001, 2002, 2003, so on and so forth. That's 5 years. So we're going to plug this in to exponential growth. And they already laid out the formula for you. Technically, this is an A. A equals, so it's your 227,200 times the number they gave you here, 1.8087. And then you just take it to the 5th power, and you plug that into your calculator, and you get $344,791.10. Okay. Okay, on to chapter 8. What is a function that models each variation? So remember we did direct variation and inverse variation. It says x equals 5 when y equals 15, and y varies inversely with x. So your just generic equation is this, right? That's varying inversely. So we're going to plug those numbers in. It's going to be 15 equals k over 5, and then we're going to multiply by 5 on both sides, so we get 75 as our k value. And then we need to plug that back in right here. So our answer is going to be y equals 75 over x. All right, number 2 here. Z is 6 when x is 4 and y is 3, and it says that z varies directly. Remember, directly would be k times something, so directly with y, and inversely, so divided by x. Okay, so that's your general setup, and now you plug in the numbers. So 6 equals, k is what we're going to solve for, y is 3, and z is, no, I did z, sorry, x is 4. Okay, so now we're going to solve that for k. So I'm just going to multiply by 4 on both sides. So 24, and then you get 24 equals 3 times k, and we're going to divide by 3. So k is 8, and then we just take that and we plug it in for k here. So z equals 8 times y over x. Okay. Number 3, z equals 8 when x equals 2 and y equals 4, and it says z varies jointly with x and y. That means we're multiplying both of them. So z equals k times x times y. And then we're going to plug in the numbers. So 8 equals k times x times y. So 8 equals k times 8. Well, if you divide by 8, you see that k is 1. So really what you're writing here is z equals 1xy. Technically, you wouldn't have to put the 1 in, but it helps you to see what your k is. So that would be your equation. Okay. Number 4, if a gear with D teeth does P RPMs, how many RPMs does an attached gear with C teeth do? Remember, this is inverse variation. When it's inverse, we take products. So we're saying D times P is going to equal what we're looking for times C. Well, if we're looking for what that X is, we would have to divide by C. So that X, the unknown, is going to be D times P over C. Okay. And then number 5 is similar idea. Okay, suppose the supply of food will feed 24 students for 5 days. How long will the food last if there are 6 more students that join the team? So remember, when one is going up and the other is going down, that's inverse, just like number 4. So we're taking products to find our answer. So if it's 24 students for 5 days, 24 times 5, how long is it if there are 6 more students? So we're not doing 6 times x, we're doing 24 plus 6, which would be a total of 30 students times however many days it would be. So if we solve that, divide by 30, we're doing 24 times 5 divided by 30, so our number of days would be 4. Okay. Number 6, if I can go 200 miles with 8 gallons of gas, how many gallons of gas do I need to go 350? This is direct because as miles goes up, gallons goes up. So this is the one we write as a proportion. So 200 miles for 8 gallons of gas is going to equal how many gallons for 350 miles. So miles are on top, so we want to keep miles on top. 350 miles for how many gallons of gas? And then you'll cross multiply that, and you get 200x equals 2,800. And then we would divide by 200 on both sides. So x equals, and this would be 14 gallons. Okay. All right. Simplify and state restrictions where needed. Starting with number 10 here. So if you look at what we have, I think on these ones, it's easiest to do a little simplifying first. So I do some of the like cross canceling. So 4 and 24, if I divide both those by 4, I get 1 and 6. 10 and 5 would be 2 and 1. Okay, you have x and x to the third, so that's going to get rid of one of our x's, so it's going to be x squared here. And then y to the fourth, and y is going to make this y to the third up top. So if you look at what we have right now, we have 2y to the third over 6x squared. So we can still reduce one more time here. 2 over 6 is going to be 1 over 3. So we just have a y to the third on top, and then a 3x squared on bottom. And that is our simplified answer. X technically here cannot be 0, right? Because if x was 0, then our denominator would be 0. Technically here our y value wouldn't be 0 either, because if we plugged in a 0 here, you can't do 4 times x divided by 0 to even start the problem. Not super concerned about that restriction, but that's what it would be. Number 11, you have, first we're going to factor this. So if you set it up, what can you multiply to get negative 15 that you can add to get 2? That would be 5 and negative 3. Okay, so this is going to be x plus 5 times x minus 3 in the numerator over x minus 3 in the denominator. And then remember, when you divide, you multiply by the reciprocal. So that's going to be, flip this over, a 2 on top now. And then x squared minus 4, that's difference of squares. Remember, difference of squares, you take the square root of both and you add one and you subtract one. So it's going to be x plus 2 and it's going to be x minus 2, like that. And then we can just multiply it all together. You don't need to find a common denominator when you're multiplying. Remember, don't worry about a common denominator. So we're going to do some slashing here. X minus 3 and x minus 3. Looks like the only thing that we can slash. So it's going to be 2 times x plus 5 on top. And then on bottom, it's going to be x plus 2, x minus 2. And then your restrictions, x cannot be a negative 2, a positive 2, but there's actually one more. If you go back up here, right, or here, x minus 3, so x can't be 3 as well. So it looks like that. Okay. All right, number 12 here. For this one, we're adding, okay? With addition, you do need a common denominator. So we're going to find a common denominator by just multiplying these two things together. So over here, we need to multiply by y minus 2 over y minus 2. Okay, and then we're essentially multiplying by 1. Over here, we're going to multiply by y minus 1 and y minus 1. Essentially, again, multiplying by 1. So we get y times y minus 2 over y minus 2 times y minus 1. Oops. Okay, and because we're adding, we already have our common denominator here and here. So I'm not going to write it separate. I'm just going to write it all on the top line here. Plus, and now this, y times y minus 1. Okay, and if you want to distribute right away, you can distribute right away. I'm going to do that here. So distribute this and distribute this. It's going to be y squared minus 2y plus y squared minus y, okay, over this same thing again. I'm not going to write it out. We'll write it out at the end. And then if we simplify this, y squared plus y squared is 2y squared. And then negative 2y plus negative y is minus 3y. and that's going to be over y minus 2 times y minus 1. Okay, and that's as simple as we can go. So we're going to leave it like that. And then our restrictions, y cannot be 1 or 2. Okay. Over to here. So we're going to do some factoring. If we factor this denominator here and factor this denominator, first of all, this one's a difference of squares, right? So this would be x plus 4 and x minus 4. We square root both sides. This one, if we lay it out, it's a negative 8 on top and a negative 2 on bottom. So what can we multiply to get negative 8 that we can add to get negative 2? That would be negative 4 and positive 2. So that's going to be x plus 2 and x minus 4 here. And then we need a common denominator because we're subtracting. We're not multiplying and dividing. Okay, so we do need a common denominator. Well, the thing that we would need to do on this side, we would need to get that x plus 4. So we're going to multiply top and bottom by x plus 4. Okay, and then on the other side, we don't have the x plus 2. So we're going to multiply top and bottom by x plus 2. Okay, now we simplify. We're going to do, let's do this. I'm just trying to think how this is least confusing for everything you've got going on in this one. I'm just going to rewrite it so it's neater. X plus 4 times x minus 4 over x plus 4, times x plus 2 times x minus 4. Okay, so that's our common denominator, so we don't really need to rewrite the denominator again. We would just do minus, and then it's x minus 2 times x plus 2 is what we're looking at. And now from here, we can simplify. So this is going to be, if we distribute here, if we FOIL, x squared minus 4x plus 4x is going to go away, minus 16, okay, minus, and now FOIL this, x squared plus 2x minus 2x, so that's going to go away, and then minus 4. Okay, be careful with this because you're subtracting the whole binomial. So when we simplify this, it's x squared minus x squared goes away, and then this is negative 16 minus negative 4. So that's going to be plus a positive, right? So negative 16 plus 4 is negative 12. And then we still have our denominator. So it's going to be x, what did I have? X plus 4, x plus 2, and x minus 4. Okay, so that'll be your answer. Your restrictions, x cannot be a negative 4, a negative 2, and a positive 4. All right. Number 15. So this one, you are going to do a little moving around. You have 9/28 here. We want to get that over to the other side to isolate the x. So it's 3/4, which if we think of that in 28ths, if we multiply by 7/7, this is 21/28, right? And we're going to take away 9/28 from both sides. Okay, so this is gone. And now we have 3 over x plus 2 is equal to 21 minus 9 is going to give us 12/28. And now all you need to do is cross multiply. So it'll be 12x plus 24 equals 3 times 28 is 84. And then solve. So take away the 24. And you get 12x equals 60. And then divide by 12. So x is 5. Okay. 16 we're skipping. Hopefully you didn't do that one. That was in the directions. And then 17 is a little fancy. We're adding and subtracting. We're adding here. So we do need a common denominator. So our common denominator is going to be x minus 2 times x plus 2, because that's what we have both of. So we're going to multiply this by x plus 2 over x plus 2. Okay, we're going to multiply this one by x minus 2 times x minus 2. And we're going to multiply this last one by x plus 2 times x plus 2. Okay, and then we'll have our common denominator. So let's FOIL this. First, outer, inner, last is going to get us x squared minus 4x plus 2x minus 8. Okay, and that's over our common denominator, x plus 2 times x minus 2. And that equals, and then we'll FOIL the next one here. This is x minus 2 squared. So if you remember, difference of squares like this, you take the square of the one, and then it's minus 2x minus 2x, which is going to be minus 4x. I said that wrong. Sorry. X squared would be first. I'm going to write it this way so I'm not making a mess. X squared minus 2x minus 2x. That's minus 4x. My bad. Plus 4. Okay. So that's here. And again, that's over our x plus 2 times x minus 2. Okay. And then it's plus. And now on top here, we would just have x plus 2. Again, over this. And since we have our common denominator here, let's just do this. Let's just call that our whole denominator, and we're adding these together. Okay, so let's do some simplifying again. We have negative 4x plus x. So this is going to be on top x squared minus 3x. And then we have 4 plus 2, so plus 6 on the left, equals what we have on the right here, x squared. Negative 4 plus 2 is negative 2x, and then minus 8. And now here's the deal, guys. Technically, we have a denominator here, but it's the same denominator, right? It's over the same thing, which means these two things have to equal each other if they're over the same thing. So I ditch that at this point and just solve for x right now. So if I take away x squared, this is gone, this is gone. We're going to add 3x plus 3x. That leaves us with an x over here. And then we're going to add 8 and add 8, which leaves us with a 14 over here, and we're done. So x would be 14. Okay? That is 7 and 8.